eMarsity is a WSQ approved training organization, and WSQ here stands for Workforce Skills Qualification. We are also IBF accredited, and IBF here stands for the Institute of Banking and Finance. On top of that, we are also part of the NTUC UTAP approved list, and the UTAP here is actually the Union Training Assistant Program under NTUC. We offer quite a list of courses which you can look up from our website. And the session today is in collaboration with the SAFRA Digital Media Club, which is a gathering of people with common interests. And the common interest here is in the digital media, which covers social media as well as a whole lot more. Here is a place where people of the common interest get to come together, network with each other, and you'll also have digital media professionals who will share knowledge and experiences within sessions that are being held. And you also get to have your hands-on digital media trends and harness digital media skill sets during the sessions that are being held. Not only you get involved and get to network, but you also get to learn, including things on content creation from the industry experts. And apart from just participating in activities, you also get to enjoy exclusive benefits and discounts on partner products and services. So with all this, it certainly sounds very attractive for us to join the SAFRA Digital Media Club. And there is a QR code here on the screen for you to scan to find out more. I'll leave it down on the screen for a while for you to scan and find out more about the SAFRA Digital Media Club. And one of the promotions that's available for you because of your participation here today is a mobile plan from Vivify. And here is a special promotion for SAFRA members, where from the usual price of $40, you get to enjoy $35 instead for the first 6 months. What you need to do is to use eMarsity as the promo code during your checkout when you purchase this plan. Vivify is also the MVNO that utilizes the network provider in Singapore. And this MVNO is the mobile virtual network operator that is becoming more common in Singapore as well. And this plan, which is on promotion, is actually 180 GB for $35. And this is contract free. And certainly at a low cost, that's attractive for you to pick up. There is also a QR code on the page here for you to scan and take advantage of this promotion. Again, I'll leave this page here for a while for you to scan the QR code if you're interested to take advantage of this promotion from Vivify. And during our session here in Zoom today, there are a few ways for you to interact. One is, which some of you are already using, is the chat function, where you can place your comments, or you can also place your answers to some of the questions that are being asked. And if you would like to ask questions instead, as part of the interaction here, please post your questions using the Q&A button on the bottom right, instead of putting your questions in the chat, because the chat, or rather your questions, may get buried in the chats among all the other conversations going on. So to ensure that your questions get addressed as part of our exchange today, please post your questions in the Q&A instead. And of course, other than asking questions, feel free to add in your remarks or any thoughts that you may have as we go through the session today, so that we can interact. This is the content that we'll cover today. when we talk about optimizing digital marketing using data science, there'll be two things that we want to first understand and get the definitions right, which is what is digital marketing and what aspect of it are we talking about? And what exactly is data science? This words or this phrase has been floating around in a lot of conversations and written about in a lot of articles, but what does it really mean? And what do we really cover when we say data science? And after we've gone through the understanding of these definitions, then let's talk about how do we combine these two things into one, which is applying data science in digital marketing. There are two parts of it that I will cover today. The first one is what used to be the traditional way, which could still be practical in some cases. And when it comes to applying data science for digital marketing, I'm going to talk about 3 examples. And of course, we'll have time to go through Q&A at the end of it. A little introduction about myself. My name is K.Sui. I am a consultant and a trainer for data science and robotics, and I have more than 20 years of working experience in Singapore and France. And in my career history, I had held several leadership positions, including head of Asia Pacific and member of worldwide councils. And I've held director roles and head of departments before. In terms of the industries that I've covered, it would be a stretch across tech, telco, banking, aerospace, e-commerce, B2B, retail, social media, and advertising. In terms of my academic background, I had my first degree in robotics and automation. Thereafter, I went on to have 2 master's degrees, one in marketing, the other in artificial intelligence. And that is why I'm able to bring to you the mixture of marketing as well as data science. On top of that, I'm also a Mensa member. That's me. So coming back to this topic that we want to talk about, when we say optimizing digital marketing with data science, we are going to talk about each of them separately before merging them to cover what aspects of it or in what ways can we leverage on the marriage between digital marketing and data science. So because we want to talk about both digital marketing and data science, so let's break it up, talk about them one at a time. First, as a start, and we talk about digital marketing first. What exactly is digital marketing? Well, we've already had a few series on this as we come along. Digital marketing is marketing of your products and services using digital means or digital technologies, which can cover internet, mobile phones, any digital medium. And even over the past sessions that we had in this Digital Accelerator program, we've also covered a few aspects of this, which is like the search engine marketing, the Facebook ads, the social media, organic search, organic reach rather. And as a digital marketer, what exactly you want to achieve or want to get when you say you want to use digital marketing? Well, a lot of times the idea behind it is that you would want to have a strategy, which is a series of actions to help your company achieve your goals through a selection of online channels. And you would want to have the right balance in your marketing through channels such as paid, earned, as well as owned media. So this is what we say, this is what we mean by digital marketing when we want to have this coverage. So it is marketing, which means that you want to bring about awareness or knowledge to the audience about your products and services through digital means. And next, we want to talk about data science. what exactly is data science? Is a lot that has been talked about. There is also the extension beyond the data science. People talk about data analytics, people talk about artificial intelligence, but what exactly is data science to us here? So let's take a poll. Please go to this website, menti.com, and use the code 96725696. And let's answer this question here today. When somebody says data science, what comes to your mind? Sometimes you get to hear about it in conversations. Sometimes you read about it in the articles. You hear mentions of it in the news as well. And it is becoming more common for people to refer to something as data science. But, well, when this kind of terms or phrases comes up in conversations, in articles that you read, or even in the news, what is it to you personally? What comes to your mind? What are the things that you would figure are related to data science? So let's take a poll and see what do we have from the room. I'm going to switch over to another screen to show what kind of results we're getting. Yeah, the results are still streaming in. Yeah, let's have more people take part in the poll and just give us an idea, what kind of thoughts do we have from the room here today? When somebody mentioned data science, what do you think about? Here we go. When somebody says data science, wow, what comes to your mind here? We have a mixture of a few thoughts, analysis. Somebody say chim data, very interesting. Data analytics, data analysis, machine learning, too technical. Wow. Statistics seems to be common. Analysis, studies, something measurable, numbers in graphs, studies here. Well, yes, interesting. Well, thanks for your contributions. Thanks for your inputs. So let's switch back to what we were showing. Well, we have expressed our thoughts, but some of the other related terms or words that comes along when people mention data science are some of those which we have already mentioned. People think about analytics, data mining, predictive information, machine learning, and all these as being related to data science. Well, how true is that? Well, data science in its formal definition is actually an interdisciplinary field that uses scientific methods, processes, algorithms, systems, and the intention here is to extract knowledge and insights from both structured and unstructured data. Well, that's quite a mouthful. What it means is we use certain scientific methods to look through or to plow through a lot of data in order to derive something meaningful out of it. So that's what we aim to do in data science. And we apply knowledge and actionable insights from this data across a broad range of application domains. There's a lot of context, there's a lot of different industries where we apply data science. It's almost ubiquitous now that everybody thinks that data science can be applied in almost any field or any industry, which can be true to a certain extent. And within the study of data science, it actually covers quite a few areas. It includes things like data engineering, data mining, cloud computing, database management, and quite a few of all these other areas. So it is very broad, and there are a lot of things that comes under data science. And if you were to ask the academians, or rather if you were to ask colleges, universities, what do they cover in data science, they could reply and say that anything that's related to the study of data would be put under the big umbrella called the data science. So that is one of the definitions that we use in describing what is data science. Well then, now that we have learned what is data science and what is digital marketing, the next question is, how do we integrate or combine or link these two together in order to derive something meaningful out of it? Because we talk about data science as something we can apply within the context. So now, if we were to zoom in and say, let's apply data science within the context of digital marketing, how do we do that? So let's talk about two aspects. One is what used to be done in somewhat more statistical manner, and this is not new, it has been around for quite a while, which is to look at the marketing funnel. So in marketing studies, we always talk about the conversion, which is how do we view or understand the psychology of our audience when we want to say, let's bring our products and services out there in order to bring them in. So first of all, the first layer within the funnel, we always talk about awareness, which means that we want people out there, our audience, and specifically our target audience for the product and services that we have as our business, to know that our business exists and we have this kind of products and services to offer. So that's the awareness layer where we say people know about us. And when people know about us as a form of provider of products or services, then the next thing we want people to think about is to consider your product or your services when they have a need, which means that when they think about wanting to buy food, for example, versus other food providers, they will want to come to you. And that is the consideration part, which means that they have a preference and they want to consider purchasing your products and services versus your peers or your competitors. And the actual purchasing would then be the conversion layer, where you convert them from just being somebody who is browsing, somebody who is just looking into, somebody who is actually a customer. A customer here is defined as somebody who actually make purchases of your products and services. And if they keep doing so, they keep coming back to you, that's where it comes into the loyalty layer. And if they keep coming back, and not only that, they pass on the word of mouth and ask others to also come and purchase from you, well, that's advocacy. So this is the marketing funnel that is oftenly being measured as part of marketing studies. And in a traditional marketing analytics, what we do is we want to measure what is the conversion from one layer to the next. How many percent actually go from awareness to consideration? And further on, how many percent of people who are in the consideration layer moved on to conversion and so on? And that is that requires some data to be collected from each of these layers in order for us to be able to form the statistics and study the conversion rates. And what do we do when we are able to see these kind of conversion rates? Well, it is not just looking at them as numbers, but instead it is something for us to think about. If you see that you have high conversion from awareness to consideration, but very low conversion from consideration to conversion, well, that is where you need to start looking at these numbers to look at what is the right marketing strategy in order to pump up the percentage or the numbers of conversion from one layer to the next. And that is where it helps you to measure how much you're spending for marketing by the time you get conversion versus how much, or rather the results that you get from conversion, how is that compared to how much you are spending in order to bring in people to be aware and to have a preference and to purchase. So that is the kind of conversion rates and the marketing ROI that will typically be measured in order to help you know where are your spending and where you can optimize and where you could further fine-tune your marketing spend in order to improve your marketing performance. So this is something that is done traditionally when we talk about measuring marketing ROI and looking at options or optimizations within the marketing funnel. However, this is rather mathematical. There is no machine learning involved in this. There is no deep learning or any of the data science. And this can, of course, be extended to include some elements of data science as well after you have done the initial analysis. However, what I would like to lead us to from here today is to talk about optimizing with data science instead of just looking at it from a very traditional analytics method. So I'm going to bring you to 3 use cases of how we can apply data science in our digital marketing. Well, one of them is the recommendation engines, and the other one is e-commerce personalizations, and the last one will be customer segmentation. So the first one on recommendation engines is about analyzing our customer traffic and purchase data from all the users or all the customers that you have in order to provide recommendations of products and services. Well, this part here, we are talking about digital marketing, but if you were to imagine this to be a brick and mortar shop, the equivalent of it is when you see a lot of people who walk into your shop, and well, the way people browse within the shop has to do with the layout of the shop as well, right? So of course, then the equivalent of it is how are items being laid out on your web page? Well, that is the equivalent of how things are laid out within a shop. So when people start walking around a shop, typically as a shop owner or even as a shop assistant, you would notice that people do have a certain pattern when they walk in. So if the person who walks in is a lady, and you will tend to see that most of the ladies would go towards looking at dresses, shoes, handbags, and those were the things that they will gravitate towards, right? And if your layout is such that you have shoes on display, followed by dresses, then of course it's a tendency that people who will just walk along will frequently look at shoes followed by dresses. However, even though that is your layout, it is also possible that people, after looking at shoes, they can see that the dresses are on display, but they can walk past it and straight away go for something else, perhaps straight away head over to handbags. And that could tell you that, this is one kind of browsing pattern where people who are interested in shoes, the very next thing they tend to prefer to look at are handbags rather than dresses. Perhaps there is some psychology about after looking at dresses, they want to find a matching handbag to the shoes. Handbags and shoes need to be matching. Perhaps that's the psychology of the shopper. And so, therefore, in a similar fashion, when you translate that to online marketing, when people are browsing your website for products and services, you can also see some kind of pattern where majority of the people who come in to the website will look at certain parts of the website or certain groups of products or certain categories of services. And right after that, the very next thing that they look at tends to be something related or something of an interest to them. There is a comment here from Dawn on whether that's associated rule mining. Somewhat, yes. There is an association but rather it is not just looking at association, but rather we are looking at data in order to help us identify a certain pattern of browsing and purchase. Because the things that people browse, you may think that a lot of people are looking at dresses, but is that the actual high volume purchase? That could be something else. So traffic, online traffic or browsing and actual purchases are actually treated as two sets of data whenever we do analysis of marketing. And when we say build a recommendation engine here, we are talking about because of the large volume of data that you have, and you therefore have knowledge about typically when people start looking at one thing, what could be the most likely next thing that people could be looking at. So then it forms the idea for you that how about you provide that as recommendation, such that even people don't start to think about it, but because from your data, you know that a lot of people who start looking at one item has a tendency to look at another. For example, people who start looking at shoes has a tendency to think about, what about a handbag? And therefore, before even they start to browse handbags as a second item, how about you provide a recommendation? Hey, look, you're looking at this pair of black shoes. How about a black handbag? So that is the kind of recommendations that can be built by using data science. And it also improves product discovery by automatically surfacing this kind of relevant products from a catalog. Because if on the page where people are looking at shoes, perhaps they are not aware that, oh, you actually also sell handbags. Because when they're looking at shoes, they could be looking at all these other variety and variations of products that you have. And they could be spending a lot of time just looking at shoes. And so if you were to pop up and be able to recommend to them something else that could trigger their thinking, well, why not, right? So let me give you an example of what it looks like when people have recommendation engines on the website. Let me share this screen with you. So look at this. I've picked one of the retailers that all of us are familiar with. When you see the logo, you should be familiar with this. This is Under Armour. So you see this is the layout of their website, and they would have these categories of items that are being sold. By the way, when you see this curry, at first I was a little surprised that Under Armour sells curry. Actually, it's a brand of products. It's not the curry that you eat. So here, let's say I'm interested in new items that they have put up, and I click on this new, and it comes to this page. Wow, I see bags. Interesting. I scroll down, I see a beanie, I see shorts, I see shoes and slippers. How about if I say I'm interested in these black color shoes? Here, let me click on it, and then I get to see details, right? So I will be thinking through, interesting, how much is it? What are the sizes? And so I will scroll down and I get to see more pictures of the shoe, this pair of shoes. And look at this. See, you may also like. So these products that shows up at the bottom here, which could be other pairs of shoes, is done through recommendation engines. And there could also be reviews. Well, in this particular case, they have shown other pairs of black shoes. But in some cases, it may not just be shoes. It could be, oh, if you buy shoes, perhaps you want to think about buying socks. Yeah, why not, right? So that is one example of recommendation engines. And where would recommendation engines come in handy is when you want to recommend other items that could be of interest, simply because majority of the other shoppers have shown an interest in these other items when they start looking at the first item. And in order to further attract these shoppers to make that purchase together with what they're looking at, you could even extend and give a discounted second purchase for the items listed. Or you could even think about, hey, it seems a lot of people tend to buy these two products together. How about if I can put them together as a bundle promotion and attract more people to make the purchase? So these are the kind of things that we get from recommendation engines as a result of putting together browsing data and purchase data. So this is what recommendation engines could look like. Now, the other one is e-commerce personalization. Well, we talk about recommendation engine as a way of compiling data from the masses and say that since majority of the people have a tendency to look at handbags after looking at shoes. So perhaps, well, we think that you may also be like that. But sometimes it is not. Sometimes there could be things that are peculiar or just very unique to yourself. And this is where e-commerce personalization could come in. And this is done through analyzing shoppers' behavior and predict the preferences and personalize the product list for them. For example, although a lot of people look at shoes followed by handbags, if you're a lady, perhaps that could be common. Or if you're a guy, perhaps, after looking at shoes, you think that you may want to buy some socks. But how about you yourself? You feel that, no, I'm not like all the other people out there. I'm a little different. After I look at shoes, perhaps, I look at caps. And that is my tendency or my own personal preference. So if you could capture that kind of individual preferences and personalize it for that particular shopper or the user, well, that would certainly up your game in your digital marketing. And we can actually do that by using behavioral data that has been collected from the shoppers and show up what is most relevant products for every shopper every time. Because as an individual, there could be, well, just peculiar shopping habits or preferences or inclination towards certain items that could be different from the others. So these kind of personalizations is what you can apply in your e-direct mailers with your personalized list of products, or you can even personalize the list of products on the very first page, the home page, after the user has logged into your website. Because of the login, you can identify who is this particular user. Therefore, you can show items that are of stronger preference to this particular user. Well, instead of you having to slowly analyze one by one, this user has this personal behavior, you can actually use data science to plow through this large volume of data and come up with this kind of personalizations. So that is one of the other ways of how we can apply data science in digital marketing. One other use case is customer segmentation. This has to do with grouping of customers, using certain characteristics of customers. And then why we want to segment our customers is because sometimes there could be a different way to target different kind of audience. For example, one of the typical way of marketing is you may want to have a different ad that is being featured where you want to make the message more attractive to the ladies versus to the men. So because you know the gender of the shopper or the gender of your audience, you may want to have something that appeals to them. And hence, that is one example of how we intentionally segment for the purpose of marketing. So if to the ladies, perhaps something more floral, something more flowy could be more effective versus, well, if you show the same kind of messaging or same kind of graphics to a guy, they may brush it off and think that, not for me, I will not look at it. So that's one example of how segmentation is being applied in marketing. And because customer segmentation actually drives better results through the actionable characteristics. And one of the characteristics that we often want to analyze with regards to our customer is their purchasing behavior. How often do they purchase? And what kind of volume do they typically purchase? And what is the repetitiveness of their purchase? So there is a term in marketing which is called RFN, which refers to the recency, the frequency, and the monetary value of their purchase that is being used in marketing analysis. And here in customer segmentation, if we were to do it manually, because of the data that we collect about our customers, we may end up looking at separating them by geography, by areas, by gender, by their age group, occupation, and certain characteristics that could be easily identifiable based on the data that we collect. However, if we were to use data science and apply machine learning segmentation, we can actually do even more. We can include things like the browsing behavior. People who has a tendency to browse in a certain way, then you could perhaps target them in a slightly different way. If people are just very quick, they just look at 1, 2, 3 pages, the max, and then they will leave the website. Versus people who will browse through, look at what you have on your promo list, look at what you have on your latest news, and so on. Well, that is a different browsing behavior. And also purchase history or channel preferences. What is the kind of digital channel that they frequent? Is it through the mobile? Is it through the web? Or is it through social media? Is that their preference? So now, what I'd like to do next is to show you an actual application of data science where we apply customer segmentation. So let me stop the sharing here and switch to another screen to show you. And this is an actual Python codes. And I'd like to show you what it looks like. Don't be alarmed by what it looks like. It doesn't look pretty usually. And before I do that, there is this message which I need to show you. The codes I'm going to show you are not written by me. In fact, because Python is an open source, a lot of people within the community of data science openly share their codes with each other so that there is mutual benefit of learning from each other as well. And this code which I'm sharing is taken from Eugenia Inzogarat. That's the name of the person who wrote this code and under the MIT license. So just as a disclaimer to let you know where the codes are coming from. And this is what the codes look like. So I'm sharing a screen that shows there are these Python codes. Don't worry if you're not technical, not a programmer. I am not going through details of the codes line by line, but I want to show you what an actual application of data science look like in terms of the back end. Because we talk about a lot on the front end, what you get, what you see, but there is also this layer at the back, behind the scene, of how it actually works. So there are just some descriptions from Eugenia on what this code is trying to do. So the objective here is trying to take the data of customers and put them into groups. These groups, we call them clusters. And there are certain rules that, well, not the rules that we apply, but there are certain understanding of how do we apply certain dimensions such that we end up with different clusters of customer segments. So one of the first steps in Python programming is that we import modules, or what is also known as libraries, into our codes. And this is what it looks like. You will see the word import followed by some names of Python code libraries. Libraries are actually groups of Python codes that are written by somebody else, but they made it to be for common use, such that you can actually just bring in that whole chunk of code through by calling this as a certain library, so that you don't have to rewrite certain commonly used functions, so that you don't have to repeat certain instructions. For example, this one, pandas, is very commonly used when we want to process large volume of data. So instead of writing from scratch, what are the instructions to carry out certain analysis of data, we will call this library into our code and use them because of convenience. And you will have sklearn, which stands for scikit, scientific kit, as common library learning as well. The top portion here is just bringing in different libraries for us to apply within this set of codes. And thereafter, that just sets the background and the environment for us to start writing the Python codes. Thereafter, there is the step of reading the data. Well, what we mean by reading the data is that usually the data will be stored in either some database or some file, and it remains as a detached element from the code. So unless we are able to bring that in and let the data be absorbed into the code, we won't be able to do the analysis. So bringing in the data to incorporate it into part of our code is what we mean by read the data into our codes here. And we store the data in the form of a data frame, which is almost like a spreadsheet, which has a table capturing data in rows and columns. So that is what a data frame looks like. Here's an example, well, or not an example, this is the actual data frame, just that it is showing a sample, which is the top few rows of the data frame. And the one that you are viewing here is just one of the many ways of how Python codes can be presented. And I am using a notebook to show you the Python codes. There are other ways of capturing Python codes. Some of it is purely just codes without all the explanations in between, without all the tables being shown. That is also another environment through which you can view Python codes. However, I thought this could be a little more interactive for us to look at codes versus some elements of output from the codes, and hence this view is called the notebook view. So after we have brought in the data, incorporated into our codes, then we can start using the code, using this data in our Python codes. And one of the first few steps that we do is actually to look at high-level view of our data. This is what we mean by exploring the data. So we want to look at, oh, this data, how many rows, how many columns, what kind of information do we have? And here is the data showing us that there are these columns within the data set. There is a customer ID. Name is not required because we just want all the customers to be anonymous in order for us to put them into clusters or segments. And we have gender. We thought that gender could be useful information to group the customers. We have age, we have annual income, and we also have a spending score. Annual income is in terms of thousands. Spending score is a measure of how much they spend when they are making purchases from your particular store. Okay. Well, yeah, some people like to scare the others by saying if you don't have programming background, it's difficult for you to pick it up. Well, the truth is that Python is one of the easiest to learn among all the other programming languages available out there. And that is why it's becoming popular. And in fact, in City, we conduct courses on Python to people without any programming background at all. So that's one of the courses that we offer. And after going through that course, you will be able to understand every single line on the page that I'm showing now. But today, it is not a lesson on Python, but rather as an introduction to you on what Python looks like. Okay. So here, one of the few things that we do in the beginning is to see whether there's any missing values, because if there are, then we need to find some ways to patch those missing values. So very fortunately, this particular data set that we use does not have missing data, does not have missing information. And we also check to look at the integrity of the data to make sure that there are no duplicates. So true enough, there isn't. And then we'll also look at what kind of data is being captured. Is it numerical or is it in the form of words? Because when we want to do segmentation, well, in fact, when we want to apply machine learning, the computer actually is doing a lot of mathematical calculation in the back end in order to produce the results from machine learning. And because it is mathematical, the preference is to work with numbers rather than work with words. So for example, if gender is given as male and female, not given as 1 or 0, then we will need to find some ways to convert words into numbers. And these are part of the data science skills that people with knowledge about Python will be able to apply. So after we have had an overview of the data set, then the next thing is we want to look at some descriptive statistics and distribution. Well, don't be put off by the word. It is just looking at some information in order to give us an idea of where is the tendency or where does the data skew towards. So here, when we chart them, we see that, oh, spending score has a certain peak in the middle in terms of what is the majority. And when we look at the age, we see that there is a tendency of the younger age to spend more as opposed to the older one. And then when we look at the annual income, we see that a lot of them falls within the bottom half of the annual income range. And perhaps the higher income group tends to shop somewhere else other than in this particular shop. We'll also look at what is the proportion or the distribution between male and female. Yeah, quite typical, a little higher on the female side. And then next, what we want to look at is what is the correlation between the parameters. Correlation here means that is there a relationship between any of the attributes or characteristics of the shopper? Is gender somewhat related to spending? Or could income be more related to spending? You know, which of these could be more related? So that is what we aim to uncover when we do a correlation analysis. And this would be what the charts look like. So we put together the age, the annual income, and the spending score in order to see which of these are more related to each other. And we also have gender being denoted by different tones of blue here. So here you could see, well, if there is a distinct grouping of data points, or is there somewhat a pattern of lines that we could see? So that then lead us to think about what could we further dig into from these kind of data sets. So we look at the cluster's shape, the size, and the relationship between the variables. And one of the things that we also do as one of the analytical steps is dimensionality reduction, which means that we want to break it down into something that can be easily grouped. And one method is 4PCA, which is principal component analysis. I will just introduce you to this name, but I won't do the explanation of what is the maths behind it. But once it is applied, it allows us to see what are the relationship between the different elements. Now, in this case, one of the things that we want to do is to convert male and female into numerical data as opposed to leaving them as words for us to analyze. The reason is because, as mentioned earlier, machine learning deals with numbers. It doesn't deal with words directly, hence that conversion from words to numbers. And let me just jump to this part here. What we see from the analysis that was performed is that there seems to be a grouping here, here, and here based on the kind of distribution of data points. And it appears that annual income is one separator, the spending score is another separator, and age could also be a separator in terms of our clustering. And one of the models or one of the methods that is being applied here is k-means. And let me just scribble a little here in order to help you understand what we mean by k-means at a very high level. So when we have many data points, So data points all over the place. We would want to pick one particular data point, let's say this one, and we say, if I want to form a cluster, which means that a group of data points, I would want to measure whether the neighboring data points are near to me. So for every point that is surrounding me, I will measure what is the distance away from me as the center point. If it is within the distance that I consider as near, then I would say one cluster. So K is the distance of that centroid or the center point of the cluster to all the neighbors. Anything too far away, I would say, no, this one would belong to a different group. It doesn't belong to the same cluster as this. So this is what we mean by K-means. And these are the formula that is being used to measure the distance. And there are also a few other considerations when we say group the data points together into clusters. In this case, the consideration used is called the elbow and silhouette, which means that at which point does it bend, and say that it doesn't affect, or rather that bend, which is actually the distance of K, doesn't change even if you add more data points. So that is a mathematical part of it. But without going into the details of the maths, let's look at what happened done the analysis. So the analysis actually produced 5 clusters or 5 groups that are denoted by the colors here. There is one group which is blue over here. There's one group which is green over here. There is actually a yellow group which is very light, and it's somewhere in the middle here. May not show up very well on the screen, but there is a cluster of dots that are in yellow in the middle. And there is one group here and one group here. So it seems that there are 5 groups or 5 clusters. And why so? If we were to scroll up and look at one of the correlations that we saw, actually is this one. And this seems to be a strong correlation between the spending score and the annual income. 2 very strong characteristics of the shoppers, and that's how we get the 5 clusters or 5 groups of shoppers. So what are these 5 groups? Well, this is done through machine learning, which means that instead of us trying to sieve through or filter through the data manually on our own, just by running this set of codes, you can actually produce the 5 clusters or 5 groups and show you what are the typical characteristics of each of these customer segments. One of them is that there are these 5 grouping of annual income and spending. So if you were to see this, there are actually 2 groups of lower income. The annual income is lower than the others, which is group 0 and group 4. However, the spending pattern is different. This group has a low annual income and low spending, but this group has low annual income but very high spending. Well, there are also 2 groups with high annual income, which is this one and this one. And the pattern is also interesting, where you see that this group of high income has high spending, this group of high income has low spending, and this one is in the middle. So that is how it automatically puts all the shoppers or customers into this 5 grouping, such that when you have a new customer, you can actually just apply the Python codes to see which of these 5 groups does it belong to. How does this information help us? What we can do is to, now that we understand that there are these 5 grouping of behavior we can then tailor our marketing to appeal to these different groups of shoppers. So that is how we can apply data science in our marketing. So let me bring us back now to this slides here, where we have looked at customer segmentation and actually dig into the Python codes behind it. Then that brings us to the coverage that we have gone through on these 3 use cases that applies data science. The first one that we looked at today was recommendation engines, where we take data from all the shoppers or customers that we have. We break it down by looking at what is their browsing behavior, what is their purchasing pattern, and we form recommendations for all our shoppers. And here we looked at the personalization for individual shoppers such that we tailor to their individual liking. And here, another application of data science in digital marketing is to break up the customer into groups or clusters, or also known as segments, so that we can tailor our marketing to appeal more strongly to each of these customer segments. What is the impact of data science when it's being applied to digital marketing? Well, number one, of course, is to increase the average order value, because you can upsell and cross-sell your product recommendations. So because you personalize it, you bring up things that are more appealing to your customer, and they probably have a higher tendency to make the purchase, as opposed to if they didn't realize that these are also things available for sale. You can also increase repeat purchases and drive the higher lifetime value because of their liking on how you have provided the marketing to them. They will want to keep coming back because they say, oh yeah, you save me time. Instead of browsing all over the place, you are able to recommend products to me. And it's personalized, you understand my liking. Yeah, why not? I'll keep coming back to you. You can also manage your margin, your merchandising, contextual goals to drive your profit, sell-through, and your return on ad spend, because, well, we talked about the analysis of your marketing funnel. And if you were to couple that with customer segmentation, definitely you will be able to optimize your marketing spend such that you don't have to have broad sweep campaigns and spend money on very low returns, but instead you could be more specific. How to implement data science? Well, the very first step is you must know what objective you want to drive. You don't want to do everything at one go, but rather pick something that is specific. For example, you just want to know your customer and segment them. That is just the one thing you want to do for the start. So that becomes your objective then. And you must have your data set being prepared, customer profiles, order history, browsing history. So this would be some of the data that you want to use and have it available to prepare for the data science. And then you can build and test your data science model. The model here is like what you saw in the Python code just now. Whatever is developed as a calculation method is set within a model that can be used repeatedly. You can either engage a data scientist, engage an agency that can provide you data science services, or you can learn Python coding on your own and attempt to build some of these data science models. And then you can implement the data science model and periodically review them in order to assess the effectiveness of your data science models. Because while it can be effective the very first time you launch it, you deploy that, but sometimes over time, things may have changed. Your data, your profile of the customer may have shifted somewhat, and therefore it may call for a review of your model, and perhaps you may want to rerun that model to perhaps redo something like customer segmentation, regroup your customers, or you want to relook at how recommendations are being provided to the customers. So it does warrant a review after a period of time. So then that's why it repeats the cycle. from number 1 all the way to number 5 again. Let me stop here for questions. Quite a lot to take in. Let's see, do we have questions? Yes, we have a question here. How does metaverse marketing come in to the mix? Well, metaverse is going to be one of the channels through which you are going to do your digital marketing. And then, so it comes back to here, right? What do you want to consider as an objective that you want to optimize within your marketing? Are you thinking about streamlining your channel in order to be more targeted? Then what you actually want to set of your objective then is profile your customers such that it is more targeted in metaverse. Or is your objective trying to consider what is the spread that you want to have among all the different channels such that you are able to capture the right audience for the kind of product or services that you want to offer? Then that's where you will set what is the objective you want to achieve and then go about doing the rest of the steps. Yeah, please continue to post your questions in the Q&A. We have another question here. How do we start from data analysts before becoming data scientists? How do you start in data analysts? Well, it is a mix. Data analytics, or when we apply to marketing, we also call it marketing analytics. That deals with more maths, and it requires statistical analysis of your data sets in order to produce some kind of results. So whether it is analytics or data science, there is also a need to look at this particular cycle where you would want to start by thinking about what is it that I want to achieve as my objective, which means, let's say if the analysis has been completed, whether it is done using analytics or data science, what is it that you're getting at the end of it? What does the completed analysis look like to you? Is it going to be a calculation of what is the right mix of your spread across channels? Like what percentage should be based on your own channel, your bought channel, your referred channels? What should be the percentage breakdown for each of these? Or are you looking to look at what is the right kind of product bundling that I want to offer such that I can capture the market? So you must first define what is your objective. And from there, then when you work with somebody with the right background, you will be able to receive advice on what is the right way to apply a certain analysis in order to produce the results. Although we have talked about data science here, not every single analysis requires machine learning. In fact, there are cases where machine learning is not the best way to go. It could be that perhaps you just need to do a linear regression, which is statistical, and you just need to find the best straight line that cuts across all your data points, and that's your answer. So not everything needs to be machine learning, although that has been somewhat the hype. There is also a question or a comment here for data analysis that was mentioned. How does the process of data collection start leading towards the analysis? And what are the tools or software that we can use in between? Okay. We always start by defining the objective. and preparing and making sure that a data set is available. This part about building and testing the data model. If it's data science, yes, we apply a data science model. If it is analysis, then if it is just analytics, then we will apply the right kind of statistical model as opposed to data science model. And there are various tools to use that. In fact, there are some tools where you just have to plug in your data and you don't need to have the need to fully understand all the maths in the background, and it can produce certain results for you. There are even some tracking tools. For example, like Google Analytics is also one of the tools that allows you to have data collected and analyzed within the tool itself, because they also produce certain charts for you to view and visualize. And depending on what you're looking for, you can actually apply those data and pull out those charts to study and make decisions as well. Does data analysis require AI modeling and programming? Programming certainly helps. Python programming is how we build data science models. And actually, for a data scientist, other than programming, we also learn a lot of maths, because we are actually applying the mathematics behind the model in order to explain why there are certain outputs that are being produced. But there are also certain developed models where you are able to just take and apply into your codes, whether it's Python codes or whether it can even be MATLAB, or it can be just using Excel spreadsheet, and you can do some analysis as well. So the question on how do we start from data analyst before becoming data scientist is think about what kind of problems you want to solve, such that it forms the business context before you even talk about applying mathematics to any of this. So that context is important. Otherwise, it is purely a mathematical exercise. So what data scientists and data analysts ought to do is really solve real problems and not just carry out mathematics as if it is a school exercise, right? Hope that answers the question. If not, please repost your question if there is a different dimension that you would like to hear about. The other one is, do data scientists know Python? Python is not the only language for data science. The other one that's popular is called R, just the letter R. But Python is popular because of the libraries that are available within Python that because it is open source, you are able to pull in a lot of these libraries that are written by other people and directly apply within your codes. For example, you saw just now in the sample customer segmentation, there are a lot of libraries at the beginning of the code that were being pulled in that can be directly applied, such that you don't have to write a lot of these from scratch. So do data scientists know Python? Usually, yes. But if you know Python, does it mean that automatically you're a data scientist? Not so. You could be just a programmer. Do we need to know things like TensorFlow, Tableau, and how long does it take to become a data scientist? Well, TensorFlow is a library in Python that is commonly used when you want to build data science models. Tableau is a tool for you to build charts and visualizations. You can learn them independently. You can learn Tableau without learning Python, because Tableau is just when you have data, you want to put them into some kind of diagrammatic charts, something to help you visualize the data. There are courses on Tableau itself, or you can also learn online through available videos from the public sphere. And TensorFlow requires you to know Python codes in order to know how to include TensorFlow into your coding. How long does it take to become a data scientist, that is very subjective. Some people start small and they learn Python coding and straight away they apply. Some people take a little longer, so it is quite subjective to talk about how long. But rather than thinking about, well, technical skills is one aspect, but the other area that is important for data science is the thinking about problem solving, which means that when presented with an objective, what could be the different ways to apply a solution in order to derive the results. So that also requires a bit of understanding of the context, because the kind of solutions that you work out mathematically for real estate, for example, is actually different from healthcare. And that is also, again, different if you are doing retail. So there is a context that is important as well. Is there a no code or low code option? There are certain applications that allows you to do a drag and drop of blocks in order to build together a solution for data science. So that could also be a starting point. For example, you know something known as decision tree, and you just want to apply that. So there are certain software that allows you to just drag and drop, pull them in order to build your data science models without having to actually write Python codes. And as you go through that, eventually you may want to consider customizing your codes in order to make it more specific to your business case. Okay. There is also a question here. Can someone be a data scientist if she has no mathematical background? I won't say that we don't have mathematical background, because all of us would have studied maths as a compulsory subject in school. So even secondary school maths is there. We start off with our mathematics in data science. In fact, for a lot of people who pick up data science after many years of working, we actually go back to revise what we would have studied in our secondary school maths to apply them. So if you find that you have an inclination for maths, yeah, that's one area that you could explore. But if you can't recall much of your maths, well, perhaps you just need a bit of trigger in order to recall what was studied in school. So my assumption is that all of us, everybody, have some mathematical background. Do we have any other questions? Well, perhaps a bit related to one of the questions asked about data analysts and data scientists. There is sometimes some, perhaps, I'm not sure if confusion is the right word, but perhaps some questions about data analytics versus data science. If you were to talk to the academians, that means people who are in universities, colleges, and they will say that data science is actually the bigger umbrella of everything related to data, and hence even data analytics will come under data science. The reason is because when they prepare courses, they have to somehow group and categorize courses together under some big umbrellas, and hence anything related to the study of data is being named as data science, and hence data analytics comes under data science. But in the industry, in practice, sometimes people do make a differentiation between data analytics and data science. The difference is when we talk about data analytics, is a lot more on converging towards answering very specific questions. For example, what can I do to increase my marketing ROI? And hence, then you will look at what is happening in my marketing funnel, where do I break down the different conversion rates, and where is my weak point in one of these many conversion rates. So then that becomes data analytics, because it is specific to analyzing a particular problem and deriving the results through data analysis. Whereas if you talk about data science, it has a tendency to be more exploratory. That means it could branch out and diverge before you start to answer specific questions. Example, when people say, oh, I have a lot of customer feedback, and maybe I just want to group them according to their sentiments. How many people think well of my business? How many people think badly about my business? So that is called sentiment analysis, and that is one branch of data science. So it's very broad because it tends to diverge and put things into certain dimension before you come in and say, oh, okay, now that I've done sentiment analysis, I have uncovered what percentage thinks well of my business versus those that do not. And then the next step is, how can I improve these sentiments? Then that becomes a different analysis. So data science has sometimes has a tendency to be more exploratory and more diverging, as opposed to data analytics, which is converging towards answering specific business questions. There is also the question here, whether can somebody maximize data from Google Analytics without employing data science? Yes, it is possible. There are many ways to maximize data, not just from Google Analytics, but from any of your business data, even your purchase data, your orders, your inventory data, your flow through. All these are data that is available to you, and there are many ways to look through them and to analyze them. In fact, a lot of people who run business, they look at their numbers every day, even just looking at how much you earn versus how much you spend. That is already a form of analysis, and that is not data science as well. So yes, you can do a lot of analysis without going into data science. And whether it is disadvantages or advantages, well, of course, if you can apply advanced techniques in data science, then it is helpful, and there are benefits to it, like what we have looked at today. Let me just take the two last questions here in Q&A. The first one is business analyst same as data analyst? Who gets a higher pay? I can't comment on pay. I'm not from HR. I do not employ them, but I could say that the pay could be a very broad range because it depends on your level of experience. There are people with 2 years of working experience who are data analysts, who are business analysts, and also people with 20 years of experience, also data analysts and business analysts. So business analyst tends to analyze the stakeholders' context. That means you would have a strong understanding of how the business operation, or what is the problem statement that is being explained by a business user. And then you would want to translate that to what are the possible solutions. So it is analysis of a business problem. That is what business analysts do. Data analysts are people who look at large volume of data and then try to look at patterns from the data. And usually it will require some kind of knowledge about statistics or some branches of mathematics in order to apply into this data analysis. Is data science agency usually, in a data science agency, usually how many team members are working together? It depends on the size of the project or the size of the analysis to be done. Because sometimes a very big project, you have a big team. Sometimes small projects, you may even have just an individual working on it. So it is a very big variation, because in large projects, you will also have different data scientists who specialize in different aspects of the data. For example, if that analysis requires translating sentiments into some kind of scores, then you would have somebody, a data scientist who specializes in NLP, natural language processing. That means just analyzing text data. And then somebody else could be building a deep learning model in order to do something else. So there could also be different specializations among data scientists. And depending on the needs of the project, then there could be different people with different specializations coming together as a team. Or if it's just a small one, it could be just one person working on it as well. Yeah, so I suppose that's just to end it off for today, we have covered optimizing digital marketing with data science, and coming up in a fortnight's time is another workshop that we have, which is Google Data Studio, the new fuel for growth. There is a QR code here. You can sign up if you haven't done so. Leave it here for a while for you to capture this QR code. And of course, at Imacity, we also have a wide range of courses that you could attend and learn from in order to beef up your digital marketing. Browse more at imacity.com. And with that, a very good evening to all of you, and thank you very much for your participation in today's session.